In the first half of section 10.1, we focused on solving systems of linear equations in a new method using matrices on the calculator. You would previously learn to solve systems by graphing and finding the point of intersection, substitution, and elimination. Some of you had seen matrices before. If you hadn't, it was new to you. I prefer to use the matrices when I solve a system of equations, particularly in application problems like the two we're about to look at here. So we're now on example 7. A woman rows a boat upstream from one point on a river to another point 4 miles away in 1.5 hours. The return trip, traveling with the current, takes only 45 minutes. How fast does she row relative to the water, and at what speed is the current flowing? When you're given an application problem, the first thing you have to do is identify your variables. You can call all your variables x and y if you want. However, you have to identify what x and y represent. So we're going to call x her rowing speed, because that's one of the things that we want to find. So we'll call y the current speed. Because we want to find a speed, this is kind of alluding to the fact that you should be using distance equals rate times time. Because we want to find the rate, we know the time, and we know the distance. Okay, so when you go upstream, you're going against the current. That means we're going to subtract the rowing speed by the current speed. It's basically slowing you down. When you go downstream, you're going with the current. It's going to speed you up because it's going to add your rowing speed to the current speed. So now I have an expression for the speed using x and y, and now we're going to write an equation in the distance equals rate times time format. So let's start upstream. She went 4 miles. That's going to equal our rate times our time. And I'm going to call the time 3/2 hour because it's better than writing 1 1/2. We don't normally use mixed numbers in pre-calculus. The second equation, the one for downstream, she's still going 4 miles because she's going to travel back the same amount of miles she traveled up. It's just that downstream we're adding, and it only took her 45 minutes. That's 3/4 of an hour. This is a system in 2 variables. So the first equation is 3/2 x minus 3/2 y is equal to 4. And the second equation is going to be 3/4 x plus 3/4 y is equal to 4. I'm going to use a matrix, although you're more than welcome to do one of your other methods for solving the system. When you use a matrix, you use just the coefficients. So the first row is going to be 3/2, negative 3/2, 4. And the second row is going to be 3/4, 3/4, 4. When you use a matrix, the equation has to be in this format, which is why I reverse the order of the equation. Watch out for negative numbers, because one of the most common mistakes students make is that they plug in a positive instead of a negative, and it will throw your whole answer out. You plug the data into your calculator under the, not math, second, x negative 1, that's the matrix function, and you first go 2 to the right to edit, and I normally put all my matrices into matrix A. You have to change the dimensions of your matrix if they are not already in the dimensions you need. This has 2 rows and 3 columns, so make sure you put in 2 by 3. And every time you type in a number, you need to hit enter. The matrix will turn the fractions back into decimals. Don't worry about it. Just type it in as a fraction. It'll all be good. When you're done typing the matrix in, you quit And then you go back into matrix a second time, but this time you only go one to the right to calc. And you look for option B, RREF, open parentheses. That stands for reduced row echelon form, which is a very convoluted process for solving a matrix. That will then pop up on your home screen, and you'll need to go into matrix a third time and just stay where you are on names and hit enter. So that now your home screen says RREF, open parentheses, A. You can close the parentheses if you want. You don't have to. You can hit enter. And the third column of the solution should say 7, 1.4. That means x is 7 and y is 1.4. In other words, the rowing speed is 7 miles per hour, and the current speed is 1.4 miles per hour. Let's do this one more time, but this time we're going to do a mixture problem. Mixture problems are often used in these systems of equations sections, I should say. A vintner fortifies wine that contains 10% alcohol by adding a 70% alcohol solution to it. A vintner is someone who makes wine, if you couldn't figure it out by the context in which it was used in the sentence. The resulting mixture has an alcoholic strength of 16% and fills 1,001 liter bottles. How many liters of the wine and of the alcohol solution does the vintner use? So we're going to use X and Y, but what do they represent? X is going to be the number of liters of alcohol, or I should say of wine. And Y is going to be the number of liters of the alcohol solution. One of the equations we're going to write has to do with the total number of liters that we're going to fill. So the number of liters of wine plus the number of liters of alcohol solution is going to equal 1,000 liters. The other equation has to do with the percent alcohol in each. The wine is 10% alcohol. The alcohol solution is 70% alcohol. So these 1,000 liters that we're filling are going to be 16% alcohol. You don't have to do anything with this equation. You can leave it as is to plug into the matrix. The first row would be 1, 1, 1,000. The second row is going to be 0.10, 0.70, and 160. You'll use the same instructions that we used in the previous problem, or if you want to solve it by elimination, feel free. If you use the matrix, your last column of the matrix should be X is 1056 and Y is 44. That means we're going to have 1,056 liters of wine. And we're going to have 44 liters of alcohol solution. We'll practice more with these application problems, writing the equations and then using matrices to solve, when we talk about systems in 3 variables and 3 unknowns. And that is systems of linear equations in 2 variables, the application problems.